All right. Page 5. So this is question 6. This is on the first thing that waves do. Waves um, can change their frequency based off motion, known as the Doppler effect. Again, Doppler effect is changing frequency, perceived frequency, changing the frequency received based off motion of either the source, so either the object's moving, or the detector, the person hearing it, or the person seeing it, or um, like way, I don't know how you would, what the detector first link is, based or the detector moving. So either one moving causes a change in frequency. First one, draw a small line to show the wavelength. Wherever you are, you need to go from crest to crest there. So that is the wavelength right there. That's that one. Which person hears the higher frequency from this car? B will hear the higher frequency here. And this is because the wavelength is gotten shorter. So this is a short wavelength versus long over here. And then wavelength and frequency are opposite. So a short wavelength means high frequency here. All right, so short wavelength in front means a high frequency. Again, so for Doppler effect, as the wavelength gets smaller, the frequency gets bigger. All right. C, stationary police officer shoots a radar at this car. So somewhere there's a police officer that shot a radar at the car, reflects the frequency, bounces back off the car, and has a lower frequency. So this is kind of the reverse of the Doppler. But again, it's still because the car is moving. Is the car moving towards or away from the police officer, or is it stationary? Well, since it changed the frequency, it's not stationary. Now, it got a lower frequency, so the car must be moving away. So car, let's see, car moving away from, because they're getting further apart. Lower frequency means further apart. Further apart. All right. So higher frequency coming together, lower frequency further apart. All right, now we got to kind of interpret this idea here. So if I've got 4 different motorcycles here, let's see, they all traveling 10 meters per second. Let's see, 4 motorcycles, so 10 meters per second. We'll assume they're all going forwards. So we got A coming at the police officer at 10, B going away from the police officer at 10. Looks like police officer, is police officer moving? 4 motorcycles are all traveling. The road blaring, siren traveling. Police car, he's also traveling 10 meters per second. Oh, all right. So we have the source and the observers are all moving 10 meters per second and 10 meters per second. So we got lots of motion here. Which motorcycle here's the highest frequency? Well, higher frequency means closer together, coming closer. So we got to look at who's getting closer to the police officer. Well, A and police officer are moving the same speed, so they're not. B is moving apart from the police officer, away from it. C is moving towards the police officer, so they're going to be getting closer together. And D and the police officer are moving at the same speed, so they're going to be moving away from each other. So it looks like C, because they're both closing in. And again, 10 towards 10 away is 20 meters per second closing. So they're closing in on each other at 20 meters per second. Which one here's the lowest frequency? That would be the ones moving apart. So B is going to be moving apart. That is 20 meters per second opening. Opening or moving apart there. That's opening means moving apart. Moving apart there. All right. And which ones would hear the same? Well, even though they're moving, if they're moving at the same speed, there's no relative motion between them. They're staying the exact same distance apart, and so they would hear it. And so both A and D, since they're traveling same speed and direction, they would hear the same frequency there. All right. And that is a summary of the Doppler effect.